Quantus podcast.
I'd like to introduce yourself. You're from Poland.
Originally, yes.
Yeah.
But now 7 years outside, usually in Indonesia.
Do you want to talk about your experience with finance and tech and stuff?
So I'm quite long in IT business. Let's say I started many years ago. First, my idea was that I wanted to be architect. I want to architect and design software. So I started, of course, as a developer. And later I was changing projects to have larger and larger projects, usually in Polish IT business and some financial and telco projects. And quite early I started teaching other people as well, because I understood that it's the best way to understand something is to explain to someone else. So I was teaching in one of I think largest Polish company, Altcom, but quite fast I started with Sun and Oracle, because they have the best resources that I could learn from them things. And later I focused on in finance. I was involved in many projects, but last part of my career before I switched to startup was mostly in insurance business. So I was architecting and managing quite large team. It was cool, but later I was looking for something new, different and more innovative. And I knew that I think in Berlin, maybe in 2019, and some guys came showing IPFS and more distributed things. And I decided it's time to go.
So you smelled that it was like, oh, this is where the future is going. It's like distributed systems and IPFS
yes, it's still quite early stage, surprisingly early stage, and in many cases quality comparing to real financial businesses, I don't know, low. People don't want to think about quality, and disappointing is that people starting new networks and they don't apply even basic rules how to upgrade this test properly before launching anything. So I think still early stage, but better and better every year. And many of bad projects, fortunately, died.
It's true. Thank God for Mother Nature.
Not with us.
Recycling.
Crypto is. Somehow we are technological guys and we are focused on technology behind, but let's face it that we are dominated by guys who playing on crypto and changing value of our tokens and executing some algorithms to influence from outside.
In some sense, I like to say that the money is still the killer use case for blockchain, but it also means that you get kind of like all the sort of less savory things from the financial world as well. I think most people who don't work anywhere around finance don't generally realize just how sort of vicious the finance game can be. I mean, like it's in many cases it's very zero sum, and it it does attract a lot of like high IQ criminals essentially. But there's also, the sort of magic of permissionless commerce, and so there's a lot of good that comes out of it as well. I think it's true. I remember Moxie Marlinspike. This was I think that's his code name, but he was the founder of Signal. I think he was like head of Twitter security before. But anyway, he sort of briefly came into crypto, as in like blockchain, and sort of just started talking shit to everyone about how we're not using that much crypto. Despite calling yourselves crypto, there's not that much cryptography being used. And I remember one of his criticisms was, like, oh, everyone's using these RPC nodes, but it's basically Infura. So there's like, one company that was at the time was basically the only way to.
What's an RPC node?
Oh yeah, so it's like, so RPC stands for remote procedure call, but basically it means it's saying like, hey, if you want access to the blockchain, you can run one of the computers that syncs with the blockchain and has the most up-to-date state. You can run that yourself. That requires a server, and it's probably not something that you can like run on your phone. So then you can delegate. The other option is you can delegate that responsibility to another computer. And so they host the blockchain. They have the most up-to-date state, and they just report important parts of it to you. So it's kind of a trusted relationship. But I remember, Moxie was like, well, okay, you connect to Infura and it gives you a message, and it doesn't even sign it. So like, one, you don't know if they're lying. Two, later, if you do manage to prove that they lied, or if you know that they lied, you still can't prove it because they didn't sign it. It'd be like, and it was a valid criticism. He had a lot of very insightful, valid criticisms. I wish he would have stuck around and just like helped us fix them. But
I think most people completely don't understand this and don't care. Still, those people many people who use crypto, they don't understand what you are talking about now completely,
right.
And they think that it's early stage and it's somehow protected, but it's not.
I think there's, I think if people might be a little shocked to look under the covers and see just how,
I remember that there are many projects that they are like middlemen between blockchains, and they giving you access to fast data. It's super important in trading. You want to have, let's say you want to play between all EVM blockchains. You want to have fast access to this, what's going on, those networks, to aggregate this, calculate prices and everything. But of course, if you don't build it in your data center, what is quite expensive, you have to use guys that are in the middle. And of course, we know that modify anything is super simple and no one control them. Why?
Well, I think it just came out over the weekend that Helios, the largest RPC provider for Solana, I think that they sell your order flow, sort of like Citadel does. Remember, it came out that with Robinhood. Robinhood's trades were going through Citadel, who then like other people can pay to see the trades coming in before they execute.
Front run things, basically.
Exactly, you can pay to front run them.
Oh.
And so and it's sort of like, all right, that's the game. It's good to come up with new games, but I was thinking about like everybody wants to play the game that they're good at. And they're like, it's like, oh, I have a new game we could play. It just so happens that I'm really good at it, Okay.
In the past, I was writing some algorithms that they were calculating something in maybe 100, 200 milliseconds. And I thought that in regular financial business is fast. When I switched to RAS, I understood that 10 milliseconds sometimes is slow, and someone can do this in 5.
Wow.
And if you are connected, I don't know, you have your server somewhere in the data center in Japan close to Binance, you can do things faster than somewhere else. But it's you want to use exchange UI to trade something, and you think you are smart before you click. I will execute 1 million of rules.
Mm-hmm. It's pretty wild to you see what's going on under the covers, and that doesn't mean you can't make money as a UI trader. I mean, many people do, but
I think more long-term investments than long-term. It's not high-frequency trading rather from UI.
Right.
It's not that you're selling, buying. You're rather buying, waiting few days, calculating signals and selling. In this way is okay.
Right, it's like Balaji says, like the difference between a trader and an investor is the trader has to watch the price every day, and then the investor can just like buy and wait, and like maybe they check it every week or month or something. And I think it does kind of, being able to just like turn it off and go to sleep is a big part of the challenge of being a trader, particularly in crypto, because it doesn't turn off. So then you just have like, oh no, like I'm sweating because, I might be making or losing tons of money while I'm sleeping. So then you don't sleep. But then of course your performance goes down because now you start getting emotional every time the price goes up or down. And suddenly like that money is like, taking you for a ride, and like you're not making money. It's just like eating you. And I think it's a powerful energy, money. DEX
exchanges are, especially even without order book, but simple exchanges are super good because you see what you have there. And of course, maybe on Solana, someone can front run you. But EVM exchanges, of course, maybe it's not important if you buy for long term. Lose 1 or 2% later, you will recover from this. But liquidity on centralized exchanges is mostly usually fake. I ran for one of my tests. I took some not too big money, maybe $10,000, and I was playing one day on some pair, and I made on this maybe $5 profit. But volume, I generated a few 100,000 volume daily, selling, buying constantly, not losing, not winning, but pumping volume. From 10,000, I made few 100,000 volume without anything.
You can do that with just one person sitting there.
Exactly.
Then like
from my laptop somewhere, because it was a completely local test, just to try. And technically, we can say that it was market making. So I was providing liquidity, but I was smarter and faster. So no one could catch me. I was opening, closing, selling, buying, but always around zero.
Right. So that the high frequency, it's not just high frequency. It's generally very razor thin profit margins, and so you have to do a lot of volume in order to make it worth it.
Problem for regular people, because you see some pair and you think that people are active here. I will invest money, and
could be just be one person. Yeah, exactly. Yeah, these stats are. I think that is one of the big benefits of DEXs is increased transparency. Of course, there's still games you can play, but the whole centralized exchange game. One of the reasons it's such a highly regulated business is there's so many so much fuckery you can do. Tricks you can play on people, and you give some people zero fees. So then they can do, and generate unlimited volume from like $1, and for a while it was like, there were a lot of sort of naive statistic reporting websites early on in crypto, and so they would rely entirely on one metric, and so then you could just game that metric. So for example, my coin has $1 billion market cap. You know how I know? Because I printed 1 billion coins, and then I sold one of them to myself for $1. And then it's like, okay, wow, what an amazing statistic. Thanks, guys. This is like zeroth order.
Typical solution to evaluate your startup.
Yeah,
even
exactly.
not in crypto.
That's right. Just need one person to pay $1 for one share.
But interesting is for regular people. Let's say you see order book, and you see spread between buy and sell. All the orders are waiting, and you put something, and you see that this book is changing fast. So it means that no one is there, only market makers from exchange. And I had not so long ago, USDT is not so popular now in Europe, and I think I want to buy some bitcoins for USDT on Binance, and it was small amount and was enough to do this, to change price. And I was buying, I don't know, for maybe $3,000. So and what is volume daily? 1 billion.
Now it's gargantuan. It's in the trillions, I think.
It's probably corner case, because it was popular pair, and I was surprised that it was. I wanted to buy this, and I didn't think that it's. I will see something like this, but still not important. How looks this game? If you want to invest long term and you trust that this is good project, it's still possible and completely okay.
Exactly. Yeah. It's sort of you can mostly ignore the high frequency stuff if you're hoping, if you think it's gonna be larger than like a 1% increase in your portfolio, because it's not stocks. It's. But
I think that this moment, the market shows that people who, the beginning of this Hossa, put money in Bitcoin, probably they were the smartest guys. because Bitcoin was going up constantly to some point. So they could have quite stable profit from this, comparing to projects that started, they were super popular, exploded, disappeared, and even projects with some huge market cap now after few not years, few months. I don't think that this last round will help them to recover from those problems that they have. So it's not stable, and this is, I think, bad in Bitcoin, that in crypto, that it's really difficult to verify if you can trust or not, because you don't have in many cases no team behind, project from nowhere, pumped by few influencers, and I don't know, you open some website, you see million of bugs on there, not scaling, generated by AI very fast, and you want to invest some bigger money in this new trust that if they even didn't know how to build website, they can build blockchain network.
Yeah, I mean, there's definitely like, the sort of, I don't know what it is, but I feel like I've definitely noticed that the quality of software that I use on a daily basis seems to be slowly deteriorating. So like, in particular, Apple, I mean, we love to rag on Apple, but I just like some of the dumb stuff I encounter when using Apple products. It's like, I mean, the hardware is exquisite, but
well, it's just that pregnant man.
I mean, really, it's the pregnant man emoji that really does it for me.
But I think a few years ago, after Airbnb and few other startups, were super nice moment where UX design was focused on art, minimalistic ideas, consistency, and so on. It was good time. In my project in Poland, we had good UX designers, and we're putting a lot of attention to simplify consistent everything, to have everything consistent, and to give to our users something what is easy to use, and they are happy to use it. And now I feel that people are delivering features with AI. So more and more features, quality not important. Let's test something, add some features, but those features are low quality and not consistent, with some bugs.
Right, and I think it's easy to lose track of the user especially when you're in a large organization. It's like, okay, why are we doing this again? It's like, what's our real KPI? I mean, we don't. I like to say we don't exist without our customers, without our users. And I remember I worked in a tech startup in Silicon Valley. It was an AI startup years ago, and they had hired one guy. There were a few designers on the team, but one of them was a guy, Igor, who was just like, his job was just to make sure that everyone knew that their ideas were dumb unless it actually solved a problem for the user. And he would just I remember he'd come into meetings and just be like, okay, wow, cool ideas, guys. Wow, amazing. Okay, now let's talk about what problem does this solve for the user. And like half of the ideas just like had literally like they couldn't even make up a problem. And that was a valuable experience. That was like, oh yeah, that's right. Yeah, we like building things, but like, there's a customer on the other end.
Yeah.
And if we don't start from them and what their problem is, and they may not know exactly what their problem is, so sometimes you have to like dig into their heads, and figure out what they really need. But like, it's
if you have large team, there's always some internal game that it's difficult to hire all good people. I had many cases where I had developers in my team, and we created some generic concept, and of course business requirements later were changing, and of course this generic concept was fixed and upgraded many times, and some people couldn't let go that it's moment to get rid of this because business requirements are different.
absolutely.
We design beautiful architecture and should stay, no matter of. We can explain 1 million times this, and everywhere is the same. That's why after a few years with startups, but my previous experience shows the same, that I don't know, tech product is important and should have good quality, but without requirements and without users, there's no sense to build anything. Just for what? For our pleasure.
Sure, and you know that's fun if you're like a teenager and you're learning how to code and you just want to like sort of do a fun project for yourself. But if like you're trying to do a business, like you need people to use it, and it just must be. If we could somehow estimate the amount of time that engineers have spent building stuff that nobody cares about. I mean, I know how much I've certainly done that in my life. When I was younger, and I think it's very common, and people sometimes spend years and they're waiting until it's perfect, and then they finally launch it and they find out like actually that's not what the market wanted, and so so I feel like this like shove it out the door thing is really valuable. I mean, I call it like rapid prototyping sometimes, but not that you want to push crappy stuff in front of people, but you need to have some kind of like sense of urgency so that you start getting feedback from the market very quickly. And
so I think should be super clear communication. That let's say we are alpha or beta. We are starting now, and you can expect that we'll have a lot of bugs, but it's not serious release yet. We want to have this feedback, and this feedback should come fast. I agree, because this is most important, and I can't agree that I don't know if you have community and you are in touch with your community, they will send you million of questions, stupid question, and waste your time, because most of projects that I've seen on the Discord or anywhere else, there are some bots always that want to play and have some airdrop, but not many good ideas what to do with projects. So I think even in communities, in one project we had I think 20,000. And still only single people were giving something what was super valuable, and this is okay. We didn't have to waste a lot of time on this community, but showing those single users that they are following this what is important for now, and they somehow want to see that we think about this what is important for them is super good.
Yeah, there's a saying in Silicon Valley to eat your own dog food, which I don't like it, because it's sort of like, I don't know, it's like your customers are dogs and now you're eating with, something feels quite uncomfortable about that to me, but I love the idea, because it's, many times when I'm using software products online, I feel like I wonder, do they even use their own product? Like, I'm just like, how did you not bump into this bug? Like, does the CEO use your product? And my father was in the car business, and he would say like, he got to meet like the heads of like Honda or Nissan or Ford or, and I remember him saying, he said, what I noticed when I met Mr. Honda of the Honda family, he drove a Honda, and Mr. Nissan also drove a Nissan, but the Lexus guy didn't drive a Lexus. And he was like, and you know what? It shows in the quality of the car. So I think, like, also, what you need. Like, by using the product, you end up thinking like, oh, I tried to do this and it was difficult, so why don't I make that more easy? And I like, especially when like doing Google stuff, like trying to like make an account and sign up for things, like somehow we just always run into this weird little AI
counterintuitive, just literally feels like, people there must not be testing.
Yeah, and maybe it's because we have a separate account. I think what it is they have AI layered into their system for just like, I mean, there was this paper a while back called it said like, neural networks, the high interest credit card of technical debt. And because they were using AI internally even many years ago to sort of try to make something smarter, or try to like anticipate problems, or like catch fraud, or like all these different ways. And it just ends up creating these, like, you have multiple neural networks, different layers of the system, and then they start getting into a weird feedback loop with each other, and nobody knows why, and it's very difficult to debug because the if statement is essentially a connection of neurons that doesn't look like an if statement and has no debugger, and and I can't help but feel every time I'm like dealing with like stupid stuff in Google, I'm like I'm dealing with an AI. I'm running around in circles, and they're like, well, maybe you should try this. And then I try that, and it's like, nope, didn't work. Okay, maybe you should go back. Have you tried this? And then it's like, just end up looping around, and it's. I think there's kind of like a back to basics that I think we need to do as like as a civilization. Like, can we remind ourselves like what is important? Like, I mean, AI is cool. I like AI, not anti AI,
But
like,
I think you said something important, that the best is to build for us, for ourselves. If you build something and you use it, you feel that it has value for you. You're more motivated. And of course, there are different type of personalities. Maybe I like complexity. But I think it shouldn't, never should be like this. And I've seen this in many projects that let's say I was responsible somewhere for backend. I was constantly in backend, not checking front-end apps. And from time to time, I was opening front-end app, and first use case failed. Even login was difficult. And who is testing this app? Who is checking what feedback I have to my backend? If no one is using analysts, CEO, I don't know, some marketers, no one was opening even to execute simple use case. And there are many cases like this. So apps are only for some demo and presentations, and they don't expect to have real feedback from users and how they can survive.
Right. I think it's sometimes a symptom of like over segmentation within the organization. Like there's, people are just like, okay, I have my one little thing that I'm supposed to focus on. I'm not supposed to, no one's taking responsibility for the end-to-end flow. I mean, we were trying to sign up for something the other day, and like, oh, sorry, like you can't, so you have to call us to sign up. Be like, no, I'm not going to fucking call you. I'm going to use your competitor's product where I don't have to talk to a person who's going to take 2 weeks to get back to me, and then is going to be confused and like, just let me push a button and give you money. Like what? Like why is this difficult? And
you guys want to talk a little bit about what we're building? And I would like to hear a little bit on like the technical side and like how you guys work together too, because I find it to be very inspiring actually to see. For quite some time it was a remote thing because you were traveling, but still I felt like a lot was happening, and I think there's
we are super distributed and decentralized, I think, and it's quite interesting setup because we have few senior guys that they feel ownership. And I think to show it super simple, I think this is the most important thing. So we don't have strict task list and one guy who is checking everything day by day. If we are on track, I'm sitting in front of my computer, or maybe I'm toilet. No one is checking this.
That's right.
But valuable is that if something is wrong, or one of us see that something is important, we feel responsible to have this consistency and not leave anything that is valuable. And all we are senior guys, so we are experienced guys to see. Probably this seniority is giving us this, that we see more problems that it's possible to have even. But it's sometimes good because we can faster understand some consequences of this what we do. But I think this is quite unique, that we have ownership, shared ownership, and it's not that one guy is leading. Of course, it's like in music bands, someone has to lead this and other follow to keep consistency. But still, it's not that there is one guy and soldiers, and those soldiers are going only in one direction without anything and any without thinking where we go and what is the result. So I think it's super interesting because it's really many projects are decentralized around CEO, and theoretically we want to build something what is decentralized, but knowledge and everything is centralized in CEO. In this way, we are building here something what is more distributed, and we share ownership, and it should be shared not only to our team members, but should be expanded more, that anyone can be responsible for something if feels ownership and feel that can give something to this setup. And this is I think more innovative project setup than any standard ideas. But of course, it's quite difficult to find people who want to be active and take ownership, because now especially remote work, different cultures, it's super easy to find people who want to spend 8 hours, shut down computer, and don't think about this. I have my task, I'm finishing my task, I'm done. I have my life, different project or whatever.
Yeah, I like the military analogy, because you may have heard of this book, Stealing Fire. It's about, they studied Navy SEAL teams. So there's like sort of elite special ops groups in the U.S. military, and they talk about how they enter this kind of group flow state, where it's sort of, the leader is whoever knows what to do at that moment, and so they can very fluidly sort of like, take orders and give orders, and it's sort of, but it also kind of requires like this kind of low ego mentality, where you sort of like, it's not, if there's one guy who always has to be in charge, well, if he happens to not know what to do at the wrong moment, then everyone dies, and then you miss the opportunity for somebody else on the team who actually did know what to do. So it's kind of like a hive mind thing. And yeah, I don't think that, some people don't want to be in a hive mind, or maybe, I don't know, maybe it's just not possible for certain people. I don't know. But I do feel like we have a kind of hive mind.
Yeah.
And I like it. It's sort of like, the beginning of my tech career was in high performance computing. And it was like, I was really into threading and like how do you multitask things, and I kind of like informed from like was reading about cybernetics, and I play the piano, and then autism, and like brain modularity, and all, like this was like a very important topic for me personally, and so I was really good at the high performance computing thing, and like how to factor tasks into subtasks dynamically based on the sort of communication cost of delegating to another CPU and things like that. So, and it maps very nicely onto an organization design. I mean, there's, of course, it's not exactly the same, because with humans, when, I've heard sometimes like, you might have like a very intelligent engineer who doesn't rise to the level of a manager because he never learns to delegate. And sometimes that's because they say, well, I could just do it faster myself, which is, could be true, but also it's not, that cost isn't the same every time, right? You can invest in someone and they can learn, and then maybe they, so that cost can go down over time, and then that, and even if they don't do it as 100% as well as you do, maybe they do it 80%, and then maybe that's good enough, because now you've freed up resources to do something else, or to find another person to fill it. So there's a kind of the recursion aspect of like, how do you sort of do the mitosis, and like, okay, we're splitting the worker thread into multiple threads, and I think just distributed systems, blockchains, peer-to-peer networks. These are kind of hive mind models, and they are harder to build than like a normal server model, where like the server's the source of truth, and all the clients are dumb, and they just like ask the server, what should I do? What should I do? What should I do? And that's sort of like the easiest first version of any system, is sort of just like, okay, we're just going to have a top-down pyramid-shaped thing, versus like, okay, is there a consensus? Is there, and how do you prevent malicious infiltration? And that's the whole Byzantine generals problem. And, it's interesting. I'd be curious, have you ever had somebody intentionally insert a backdoor into code that like somebody you hired?
I don't think so.
In what context?
Well, okay, so like let's say you hire somebody to like write software for you, and then
few times we were laughing with my developers that we're building some huge financial flows, and through our system we're flowing some $1 million. So we're laughing with developers that we can take some few cents, and no one will see this, but nothing serious. Fortunately, I didn't have this, but I think in blockchain networks but it's somehow it comes from this architecture, because we see that you take some framework, and the same problem is with front-end apps, where you rely not on one library, but you have many dependencies to some external libraries. It's really difficult to be 100% sure that they are okay.
Right. Who's going to read all that code? I mean, like, especially, the dependency tree just grows in an insane rate with these things. I mean, it's like, cargo build, and then just like, okay, 1,400 packages were in blood. And it's like, okay, like, how long would it take me to read the source code of all those packages?
And this is quite surprising that many blockchain teams, and in many cases this release part or testing part is not so good. They are not perfect in those updates or verifying if this what is released next is okay or not. And I don't know, for some people stopping blockchain network is nothing to be proud, but for some it's still okay. What is said, I think, because like, of course, if you have some break in financial system when everything is still offline because you click one button and it's not visible what they do with this, but in blockchain immediately is visible because there's nothing between. There are not guys that are putting from one box to another. So with this transparency, release management and dependency management to be sure that everything what is released is tested and stable is super important. And it's those small things to users like proof that we are serious people. This is something that you can trust. It's stable. Financial product with immutable history, that you can always take something from the past and be sure that it will be always exactly in the same shape.
Well, it was interesting. I don't know if you looked into the Cetus hack. It was on Sui. It was maybe a few months ago, I think. And it was a flaw in the library. It was a math library they were using, and it wasn't even a blockchain library. It was like something deeper in the system. And it was some corner case where if you bit shifted, the rounding was off, so you would get this kind of like predictable, essentially rounding error. And anyway, it's like, and why did that happen? So it's because who has time to audit all these things? So my approach to security has always been like, okay, like, let's reduce attack surface wherever we can. And that also, I think, also helps with product design, because it's like, okay, new feature is new attack surface. Are we sure we can't cobble that together with, existing features? And one of the things I like, I spent a lot of time programming on Ethereum, and it was one of the things I really liked was how constrained the environment was. So it really forces you to think in this, very efficient way. Like, okay, like, we want to do all these things with our system. What's the absolute minimum that absolutely has to go on chain so that it's auditable and secure? But just to roll back to our previous conversation, previous startup I did, we had somebody try to insert a backdoor into our smart contracts, and I remember clearly the day I was reading their code, and leading up to it, they kept trying to insert their framework into it. They had built this like custom transmute framework, and it kind of made sense because it was an event sourcing system, but Ethereum already has events, so like it kind of didn't make sense. But I was willing to give them the benefit of the doubt. They were smart, and I was okay. And they anyway, I was like, okay, I'm just gonna wait until I'm gonna let them do this first step, and I'm gonna go look at how it works, and evaluate it. And I remember they put in the code. I was reading this. There was a function, and it had one of its arguments was authorized. Okay, so then it's a public function, and anybody could call it from the outside. So if you set authorized to false, there was this like strange, like unusually complex if statement. Like the condition on it was like unnecessarily complex, like with lots of like inversions and ands and that sort of thing. And anyway, but then what it basically came out was that if you put authorized as false, you can write events without the authorization. And I remember I was like, that's pretty weird. And I went for a walk, and then I was like, I think this is intentional. So I called, my friend who was working on the project. I said, I think that, and he's like, oh, I really hope not. Anyway, so I decided, okay, I'm just gonna have a short little conversation with the guys. I'm gonna get on a video call.
Take them on a walk.
Let's just go for a little boat ride. You're just like, hey, I know you guys love the ocean, don't you? Anyway, so I get on a video call with these guys, and they are so fucking nervous. It's like they're and one of them has his shit together more, but the other one is like visibly like can't sit still, and he has to like kind of makes an excuse to get off the call in the middle of it. And and the other guy was, they framed it. There was an accident, and I just didn't believe it. It didn't, but he was like, oh, this is why we shouldn't be involved in blockchain coding. I was like, okay, yeah, you really shouldn't.
I think now we are moving to different topic, that reading, reviewing code correctly is super important.
Oh yeah,
to understand what is going on in this project. And before AI tools, we were writing much slower, and we didn't have but of course I had quite large teams in the past, and I had many reviews waiting for me, but always I knew that my idea for review was always that flow was that not all team was reading. Always one single person was responsible for approving this. That to be sure that not read this, I read this, but who is responsible? Who checked this from end to end to be sure that it works? No one, probably, because 3 guys already accepted this. So
right, it's probably fine.
Yeah. But of course takes time, but builds responsibility. So exactly what is there, and of course now, I don't know, tons of code are generated by AI, but who is owner of this? This guy who put this to our repo. It's not AI. Ask AI. Probably doesn't remember that generated this 3 minutes ago.
Yeah, and I think it comes into the whole mental model aspect of like if you're going to audit the source code, or you're going to write it, or whatever it is, like you have to have some kind of mental model, which is necessarily going to be incomplete. Like the version of the code in our head is going to be simpler somehow than the real one. We're not going to memorize every line of code, and then of course it changes every time somebody updates it. So there's this real like sort of cognitive challenge of how do you effectively track how the thing works. And it's a deep question. I mean, I think people want to have this fantasy of delegating everything to AI, and I just I just don't see it happening. I mean, there's every abstraction leaks, and like if the AI doesn't have full view of what you and your business plan is, or maybe it does, but then when something breaks, and it will, who goes in there to fix it? Right? If nobody knows how it works, then nobody can fix it. And
so I think not big change in testing, because developers don't write any documentation, but they are okay with writing tests. And in tests you have, let's say I have my algorithm, I have in tests all corner cases. And if you start modifying my algorithm, you will break my tests. if you don't understand how it works, and this is okay.
Right, so the test kind of implicitly encodes some kind of mental model of how the thing should work.
Exactly.
And it's like another layer of kind of like that gets to monitor the lower layer behavior. And
So that's why in our governance part and treasury, we rely on palettes from Substrate, but all behaviors are in tests. So all corner cases that I want to use, I put to our tests to be sure that we correctly executing. And for example, we'll have new version of referenda palette or something, and those tests should still work. And if they fail, it means that we are changing in our governance something not correct way. So this like we have included in our code description of rules that should be applied.
well, and this kind of leads into this idea of test-driven development too, which is interesting, where you have like, sometimes people say, write the tests first, or at least write the names of the tests first. Like, it should do this, it should do that. And I think, it can be a little constraining sometimes, but it's still not a bad idea to think like that. Be like, okay, because the tests do encode your expectations of how the thing should work, and then it creates constraints that, like, if somebody changes the code and doesn't change the test, then hopefully the test catches.
So I'm curious how this works with, like, because we're building on Substrate, but we're not a parachain, so we've used Substrate's code base. And then developing on, and then taking what we want from it, but also modifying and creating our own palettes too. Is that true? Is that how it's happening? And I want to know, like, what's the challenges and what's the why build on Substrate? Why not build, on one of the others that are out there? How did you guys land on that?
It was much easier to start, and I think Substrate has quite a good modular architecture where we can select palettes that we want to use. And first idea was that our modifications, of course, we don't want to be parachain, so we don't have all this complexity connection to other blockchains. And our idea is not to be somehow consistent with Polkadot ecosystem, because we change security completely, but huge part of Substrate is useful for us, and we didn't have to modify. But of course, we have to control. And comparing to this, what is in Substrate, we took only few palettes for governance, not governance, for referenda, for treasury, and few other, but with full responsibility and control. And there are cases when we had to modify them. In those cases, we took them to our code and modify. Other cases, we are consistent, and we want to update them from time to time to be consistent with this framework and changes. But of course, as I said before, the more we have, the more responsible we have to be, and careful with this what we do, because we see that next releases in Substrate are sometimes not super predictable and stable.
Right. I mean, they may introduce bugs, and so there's a kind of a question of how often do you upgrade your own code. But it's Substrate. So I picked Substrate because I thought, one, Gavin is a crazy person, but he was also like, he's the guy who pulled Ethereum off. And I remember when I first read about Ethereum, I was like, there's no way these people are going to pull this off. This seems way too complex. It's going to have all these security issues and And you know what? They managed. I mean, it does have security issues, but they managed to pull it off. I was proven wrong. And a lot of people think of Vitalik as the sort of godfather of Ethereum, and in many ways he is. But the real kind of engineering, I think, was more. I would say Gavin is more responsible for that. He's the author of the so-called yellow paper, and it was very abstract and very verbose, and his code, is not that easy to read. But all the places where you might want to swap something out, basically everywhere we looked, we found a nice seam or abstraction layer somebody had drawn. It wasn't always easy to find it, but there was like, okay, here's where you snip if you want to change the consensus algorithm, or here's where you snip if you want to change the signature algorithm. And so it did enable us to go very fast by basically starting with a working blockchain and then do heart surgery and then do lung surgery and then do brain surgery. It's like we've touched, I think, all the parts of it at this point. But
it would have taken exponentially longer to just build a blockchain from the ground up.
Yeah, so modern software engineering is always using some existing libraries. Nothing is ever done from scratch. I mean, it's the same thing with probably not just software, but physical engineering. I mean, there's like lots of existing solutions to common problems that can be applied. So, but I think Substrate in particular gave us, let us focus on what we are doing that is unique. What's our special use case, and so like.
And they've been like audited, or have they been through like formal verification? Is there?
I don't think they've. I'm not aware of any formal verification processes for.
But there is audits on.
But audits, yes.
Yeah, and so you can kind of enter in with some level of trust because you're building on those audits, and then when you modify things, then we have to test it, and that's where this testing comes in.
Yeah, the testing and the auditing. I mean, it comes right. So basically, if you change anything, and of course, like the project is not sat still, so they audit the project at one state, and then it moves, and so then you can re-audit it. Or
in the past, they did many deep, not super responsible modifications. What is wrong, maybe, but that's why our idea is not to be super updated to last version. We first, of course, when we are starting 8 months ago. We took this what was available, but from this moment we're slowly and more carefully following this what is there, because communications channels are not so good. There's no place that you can read in one place what is problem. You see rather somewhere on Twitter or somewhere else that they found.
So it's hard to troubleshoot it really, or just make sense of it per se.
Yeah, like in terms of like if you go look at the Polkadot SDK repo, which is where most of the Substrate stuff comes from, it's just got like hundreds of branches, and many of them are like way out of sync with each other, and yet still being developed in parallel. And so it's quite a challenge to sort of figure out exactly what do you need in which version, and you can easily kind of get yourself into dependency hell by just like if you just I'm just going to update this package. Like, no, you're not. Like,
has a whole cascade. So I'm curious about the signature palette, right? Because it's like kind of the crux of like this project and how we kind of got started on this whole thing is because there's a big change that is coming in the world of cryptography. You want to talk about the signature palette?
Sure. I mean, we don't call it a signature palette, but it because it's actually at a lower layer.
Okay.
But basically, there's this big topic in Ethereum people have been talking about for a long time, account abstraction, and basically Ethereum kind of when they first made it, kind of overcommitted to a particular signature algorithm, and they didn't put a nice abstraction layer in there so that they could swap it out or have options in there in the future, and that has turned out to I think really kind of paint them in a corner in a way. Interestingly, Bitcoin had a version of account abstraction from the very beginning because they had different address types. So it's not so difficult to say like, okay, a Bitcoin address is essentially a little script that describes the conditions under which you can spend this Bitcoin, and whereas Ethereum kind of said, okay, well, we're going to turn that into a smart contract, and it's this whole like expanded set of things you can do, a larger set of more expressive conditions for how you can spend the money. But then,
just a quick question for the Bitcoin piece: is that like where I like get options to use like Sedgwick, Taproot,
Taproot? Yeah. Those are all those different address types.
Okay.
That's essentially account abstraction.
Okay.
And
then with Ethereum, sorry, I cut you off.
Yeah, so in Ethereum, they made a more expressive scripting language Solidity, the EVM bytecode. But then they kind of factored out the authentication. Are you eligible to make this? Is the signature valid? That kind of went off into a little corner, and so then to upgrade it in a backwards compatible way is not very simple. And so there's there's the account abstraction team at Ethereum. I guess they work for the foundation, and they did a good job, but they sort of had to do it at the smart contract layer, make a new kind of contract that manually in Solidity will verify your new kind of signature. And it's sort of like, because doing actually getting it all the way back into the protocol layer would break lots of things that already exist. So people have already built billion-dollar businesses on top of Ethereum. So then you go and change something. Now all these people have to update. So it's so it's quite helpful to have a certain amount of foresight in when you set up these abstraction layers, even if you don't want to necessarily use it. You don't necessarily want to multiplex at that point immediately. It's good to look ahead and say, okay, we might want to change this later. So Polkadot has an account abstraction built into it, and so it's interesting to see Polkadot didn't get as much attention as Ethereum for a variety of reasons, but a lot of the sort of things that Ethereum ended up trying to do, Polkadot did first. And I think that's also kind of, Gavin left Ethereum pretty early on. It seems like he's pretty hard to work with, but he's also quite brilliant and was a big part of the engineering success of Ethereum. So in short, that's Substrate is good tech. I mean, there's a pretty significant learning curve, but now that we've got a handle on it, I feel like many times I've been sort of surprised. We're like, wow, actually that's pretty good that they made it like that. I guess another option could have been Cosmos. I mean, at the time, it seemed like there was no good way to write it in Rust. We wanted to get the memory safety of Rust, but it seems like it's good tech as well. They have the inner blockchain protocol. So
today, decide exactly the same. Probably.
Yeah, I wouldn't change the decision. Looking back, I mean, it
was okay. Probably, I don't know. Everything was important somehow in the sense direction was okay. Now our understanding is completely different of this, but it's still comparing to this what is available on the market. It's good.
Yeah, I would definitely for a serious engineering team, I would recommend if you're going to fork something, Substrate's a good choice. It's not the fastest. You're not going to be as fast as Solana. If you're trying to outrun Solana, I mean, one, good luck, but two, maybe fork Solana. But on the other side, I mean, the first version of our project was a fork of Bitcoin. That was the first idea. It was okay, let's fork Bitcoin. Let's add a new address type and swap it in, and that actually it wasn't that difficult because of the account abstraction. And of course, there's a lot of other reasons why that's not a great idea. So we backed out of that, but it was a good proof of concept. And the bigger challenge with Bitcoin, of course, is that the migration of existing users onto new cryptography is a big part of the challenge. It's not just giving people the option to use new cryptography is probably the easiest part. And but okay, there's people who lost their keys. There's people who died, and their keys died with them, and then there's of course the topic of the block size of okay, everyone's now migrating to this new bigger signature scheme, and we need blocks to be 1 megabyte forever for some reason, and I don't know. I don't know how fast Ethereum and Bitcoin are going to be able to update, and I think people's assumptions that they're going to be notified on all progress in quantum computing is not a good assumption. Not only because it's a security critical thing, this is we're talking about a potential catastrophic failure of the system. That's not the only reason. It's also because the intelligence agencies are very interested in quantum computing because they could crack all the cryptography with it, and they're not going to tell you what they can do. They don't like, oh, that guy over there, let me call him and make sure he knows, you know.
They don't tell you 50 years later when they release the documents. What do you think they're going to tell you when they get it this month?
Yeah, by the way, we killed your president 50 years ago, but like, don't worry
Actually,
about
we're going to redact all that. No, we didn't do it. It still wasn't us.
it. We're
Don't
still
worry
not
about
sure who it was. It was some guy.
Don't worry about that.
So that's I think the danger is that people are, this is going to sneak up on people. And if they used it in an intelligent, quiet way, they might not even give it away. Be like, oh, you know, you set up kind of some parallel construction where like, yeah, we stole the money, but using a quantum computer, but we made it look like it was North Korea who did it. And we can just blame them, and then nobody asks any questions, you know. I don't know if you remember I think WikiLeaks released, there was somebody leaked the Vault 7 CIA tools, and in it there were tools that could basically make it look like the malware was written by any nation state you wanted. You know, so you're like let's make it look like the Chinese were trying to make it look like the Russians were doing it. And I was like, oh, okay. How do you do that? Well, you can put Chinese language stuff in there, and now with AI, you could probably imitate it on an even deeper level. You know, you can like, there's probably all kinds of like semantic patterns that are characteristic of, different languages or different cultural backgrounds.
It's a new culture of deception.
Well, people
with AI.
Yeah, that's right. That's right.
It's like, wow.
Years ago, there was this whole quest to find who Satoshi was, and they were trying to do linguistic analysis. And they're like, okay, because it turns out like people have pretty unique ways of talking or writing, and I think they managed to narrow it down somewhat. But I think some people claimed that it was multiple authors on the paper. They also analyzed access times to Bitcoin talk forums to see like, okay, what time of day did they avoid? So that kind of narrows down like where they could be geographically. Was it 4 a.m.?
Yeah, if it was morning or like what time?
So I mean, it's very hard to hide anything. I mean, like really, we've got this massive system that is constantly using information to send information, but you leave a trail everywhere you go and do things. So,
but you need a lot of computing power to find something.
It's also true. Right. Looking for a needle in a haystack. And yeah, this sort of, it's like you may have a large database, but is it properly indexed? Right? How do you find the thing you're looking for if you've got petabytes, exabytes of data? Okay, where is the thing you're looking for? It's a deep question. I mean, you can also ask the same question with cognition. You're sort of like, we have all this stuff that happens to us during the day, and we often forget. Even sometimes, we do comedy improv, and then like at the end we try to like review what our favorite moments were, and I often can't remember most of what happened. I was just flooded with new information, and then it was okay, look back, what happened? I don't know. So like there's this kind of magic of like, how do you index the data as it comes in so that you can later access it efficiently, and people have timeouts, they're sort of like, look for a memory. You ever like looked for a memory and then you're like, all right, I give up, and they say, what do you say? I forgot.
It's in slow storage.
Yeah, that's right.
Slow storage.
Glacial.
Yeah.
But I think if you do like kind of, program yourself to say like, okay, it'll come to me later. Like if I hit the timeout, I don't say, okay, I forgot it, I'll never remember it again. I think that's a anti-pattern, like for memory. I think you should say like, okay, it'll come to me later.
That's great.
I'd say not 100%, but like 90+% of the time it comes like within a few minutes. I'll be like, oh, I remember what we were going to talk about. It's background process. Well, shall we play a little bit of music and then wrap it up? Yeah.
Yep.